Yo guys, so today we're going to be tackling problem 11 of Project Euler. So the problem states, in the 20 by 20 grid below, 4 numbers along a diagonal line have been marked in red. As you can see here, 26, 63, 78 and 14. The product of these numbers is 26 times by 63 times by 78 times by 14, which equals, let's see, 1,788,696. What is the greatest product of 4 adjacent numbers in the same direction, up, down, left, right, or diagonally in the 20 by 20 grid? Okay, so I've done a little bit of pre-work for this one. So what I've basically gone and done is that huge list that you just saw before, I've gone and just loaded that into a 2-dimensional array. And also, because we know it's 20 by 20, I've also added up here a couple of integers just to sort of show columns and rows. The reason I'm doing them separately is just so we can see when we write our functions exactly which direction we're sort of going. And of course, as always, I've set up a little friend named execute. So the way I'm going to do this is I'm going to have 3 other functions, right? So we're going to have one that calls, like a check, say vertical. We're going to have one that says like check horizontal, and one that says check diagonal, like so. So let's get these written down. So we are going to be returning a static, can't even spell these days, static long, let's call this, let's just call them exactly what we did, check vertical. And from there, we are going to be giving a couple of ints. So int pos x and int pos y. So these are going to be the indexes for our array. And we'll just copy this signature because it's going to be pretty similar. So we're going to have check vertical, check horizontal, about there, and check diagonal. And at the minute I think it's just complaining that it doesn't return. Yeah, okay, so I'm just going to create a long called result, which by default will be set to 0, and then at the end we'll just return result. And I'll just copy this bit here so that we have 3 done. Okay, cool. So now that we've got these, the way I'm going to do it is we're going to go through each point in this grid. So we're going to start in the top left, and we're going to go down row by row. On each one of these, we're going to call these functions. So in check vertical, it'll be the top left, and it'll check, top left, second down from left on the left, third down from the left, and fourth down on the left. And it'll multiply those and pass it over. The reason I'm saying check is because, if we get to pretty much the bottom of the table, we do check vertical, checking downwards is not going to be possible because, obviously we've hit the bottom of the grid and therefore unable to do it. So, for this one, we're going to have to do a couple of for loops. So for int, let's say row equal to 0, row is less than rows, row plus plus, and for int columns is equal to 0, column is less than columns, and then C plus plus. Programming language. Anyway, so have I got this the right way around? Let's see. So we're gonna go long in the column, so it's gonna be indexed. Oh, look here. So if we do index, say 1, 3, that is index 1, and it is the third number along, so that is the column. Yeah. Cool. So we are going to be doing check diagonal. check vertical on pos x, which is just going to be our, so if we do x, y, x being the one that goes along and y being up and down. So I guess I've sort of done these a little bit backwards, because x will be which column we're in, so that's going to be column. Yeah, I've put those the wrong way around, so let's just quickly change these. So pos y, pos x, pos y, pos x, I think, and also for check vertical, so pos y, pos x. Cool. So vertical on the, so I just changed this, so y is up and down, so this is going to be our row, and then this is going to be our column. Or actually, sorry, this is going to be R and C. Cool. And also, because we're trying to find the largest product, I'm going to go long. Largest product is equal to, and I'm just going to say like minus 5,000, because everything is going to be larger than 5,000. So it means even if the first one is the largest one, we'll check it, it will be above 5,000. So what I'm going to do is, for each column, check vertical, and I'm going to store this in a long variable called vert, and then we are also going to have vertical, horizontal, and diagonal, and of course we change these functions accordingly, so check horizontal, and finally check diagonal. And then at the end here we go, let's see, if vert larger than the largest product, then we do largest product equal to vert. This is just basically assigning ours if it's largest, and again this can be changed, so horizontal, largest product equals horizontal, and if the largest is diagonal, then we change it to diagonal. Okay, cool. So this is our sort of base logic setup here. So you know, we're going to be checking vertical, horizontal, and diagonal, seeing which one's the largest product and returning that. So now comes the fun part of attempting to implement the check vertical, horizontal, and diagonal functions. So I'm just going to quickly collapse the execute by taking a look less on the screen. So check vertical, pos y, pos x. So what we are going to do is we are going to start. So we're going to start at the point and then move down from it. So moving down, and that is going to be changing pos y, which is how high up we are. So what I'm going to do is go for int I is equal to 0, I is less than 4, I plus plus. And what I'm going to do is, in actual fact, what I'm going to do is I'm going to quickly change result to 1, so that we can just sort of, right out of the gate, just multiply by it, and it's still going to work. And I know this is a magic constant per se, I don't get why, so I'll just, 1, so we can multiply to it. If it was an addition, it wouldn't be so bad, because obviously when you add to 0, it just, God, I cannot highlight today. There you go. Obviously when you add to 0, it just sort of adds on top, whereas when you're multiplying, it makes it 0. So if we left these at 0, every single answer we got would be 0, and so technically speaking, our logic product would be 0. And that is obviously not the case. Okay, so for int I 0, 0, what we do is we're going to go result times equals, and what did I call them? Numbers sub. So we are going to be pos y plus this integer that we just made, pos x. So what this is doing is, and that's why I started this at 0 and then did up to less than 4, so it'll check. So say we're in the top left, the pos y is 0, we come in, we pass in 0, 0 plus 0 is 0, so we start in the top left. When we go into our next iteration, obviously I becomes 1. So what that ends up essentially doing means that when we come through the list, we'll have numbers as pos y, so this is still passed in as technically speaking being 0. This will be 0 plus the 1, and that moves us down 1 position on our grid. And then obviously pos x. So we do this up to 4 so that we get the 4 numbers that are next to each other. What we do need to do before we check this is go if pos y plus 4, that's how many numbers we're checking, is more than the number of columns we have, then we're just going to return -1. The reason I'm doing just return -1 is because none of the numbers in our grid are negative. That means if we return -1, we know we've got an error. And we could use this to do some error checking further down the line. We'll just see what happens from there. Otherwise, obviously it turns into this, and then we return that result that we've used. So check horizontal is going to be pretty similar. The only difference being is that instead of being pos y that we're changing, we're going to be changing pos x, okay? So, again, we're going to do if pos x plus 4 is more than our rows, then we can just return -1, a little bit defensive programming. And then again for int I is equal to 0, I is less than 4, and then I plus plus. And what we're going to do is do result times equals the number sub pos y pos x plus I. Go. So again, this is just the same logic as the previous one, except instead of going down the grid, we are going along the grid. And with check diagonal, again, it's going to be a very, very similar thing. The only difference is that we are going to actually be doing it for both of these. So we're going to move along by 1 and down by 1, and that will check our diagonal. So we will actually be adding I to both of these pos y and pos x values. So we can actually just do a little bit of a shortcut here. And what we can also do is say or pos y plus 4 is more than the columns we have. And this will just check both to make sure, because you know it might be that we have enough spaces. If we're on the far bottom left, for example, technically speaking we can go along in the rows by 4, but we wouldn't be able to go down at all, and therefore we wouldn't be able to check the diagonal. So again, and just down here we're just going to say plus I instead, and then that will just return the result. So we've got our base logic here, and let's just see, is there anything else I need to add? So checking all of these, we're getting the variables, assigning it to the largest product, and yes, there is. The answer is I'm not actually outputting our answer. So here we are. Yep, that's after the loop, and then we're just going to go console.writeLine, and we are going to just outline the largest product. And actually what I'll do is I'll give a little bit of a text, so largest product equals, and then add that just so that we've got a bit more thingy. So let's go into our program. We'll just get rid of our Pythagorean triplet, and we are going to do the exact same here. So we are going to do the largest grid product dot execute. No, dot execute. I forget to make that public. That's why. Public static void. There we go. Save that. And now take 2. Okay, there it is. My mistake. So before I quickly execute this, what I'm going to quickly talk about is, so if you were doing this for something other than just this specific problem, if it was just you were getting any sort of grid in, as long as obviously it had the same rows and columns in each, like same number of numbers in each row and in each column, it could be separate. So you could have 20 rows, 10 columns, for example. You could modify this. So these rows and columns would come in and be assigned based on that. And then obviously this logic would still work. And in execute, instead of just passing in nothing, you could pass in, say, a 2-dimensional array, figure out how large it is, and pass that across. And all this logic should still execute in the exact same way. But yeah, so let's run this and see what happens. Okay, so we've got an answer. Largest product is 51267,216. Okay, so let's just pull this across to the other screen, bring back our project Euler. Let's have a look. So we've got 51267,216. Our confirmation code is 75208. And let's just hit check. Oh. Did I input our answer incorrectly? 51267,216. No. Okay, so that's interesting. Let's have a look, shall we? So I'm just gonna go here. Run. Okay, so let's hop in. And so okay, so that's not returning -1. So the results should be turning into, let me just get up Project Euler again. There it is. So this should turn into 8. I believe. And so this should turn into 8. So the result is now 8. That's good. So we are checking vertically. So let's just pull up a calculator. Just to cheat a little bit. So in this one we should have 8 multiplied by 49. Brings us to 392. Cool. So let's have a look. 2 and 392. 392. Okay, so our vertical function is working. Let's go quickly slap a second breakpoint on here. Then I'm just going to click continue. Check horizontal. So once again, let's come in. Is it more than 4? Nope. Okay, cool. So this should now become, let's have a look. It should be 8 by 2, so that's 16 after we run through these couple of programs. So 8, 16. Let's just keep checking the next one. So we have 16 by, which is apparently 352. Yeah. Okay, so that one's working. Does that mean that we have an issue on our check diagonal? And let's move in. Okay. So if was x, or yep, neither of those is true, therefore it's just doing that. So I is 0. The list gets us 8. So this one's going to be 8 times by 49. Okay, so let's continue this one through. We got 392. Okay, cool. So, I'm wondering where my thing is wrong. So let's see. This one should then be times by 31. Gives me 12,156. That's right. Very interesting. Okay. I'll be a minute. I'm going to quickly go away and see if I can figure out where this is going wrong, and I'll be right back with you guys. You know what? This is really going to bug me. I'm going to come back to this one, but I can't see where my logic's going wrong and where this is causing an issue. But I will be coming back to this one. Unfortunately, I've sort of run out of time. I've got somewhere I need to be. Didn't actually think this was going to take this long to record, so I need to sort of duck out and leave, unfortunately. It's what I'll do is I'll either say I'll see you guys in the next video, and what I'll do is I'll upload this code so that you guys can have a look at it and try and solve it, figure out where my logic's going wrong. Otherwise, what I might just do is if I manage to figure out where the issue is, tag the solution to the end of this and tell you where I went wrong, and we'll sort it out from there. I am so sorry we could not reach a conclusion in this one, guys. But seriously, thank you so much for joining me, and if you can see where it is I've gone wrong, please feel free to comment down below and let me know exactly where it is, because I am absolutely baffled right now. But yeah, so thank you guys for watching, and I will see you in the next video. Bye.